Hello everyone, my name is John. I am a high school student interested in pursuing astrophysics in a postgrad institute, and yeah, I just wanted to talk about the universal gravitational potential energy, which is quite different from what we learned before this class. So, why we can't assume the potential energy equals to mgh while playing with celestial objects. So the number one reason is because assume there's Earth here. In this equation, we're assuming that the gravitational field is a constant. But we all know that this is not true, since if we move farther away from the Earth, the gravitational field gets weaker and weaker. But is there an equation that can apply to pretty much in every situation, even though we are in an orbit where it's outside of the stratosphere, so we're no longer under the influence of the surface gravitational field? Meaning, to simplify it, let's say there's a satellite. Well, we're dealing with Martian gravity, like we're dealing with the movie Martian here. So let's say the Hermes spacecraft is in low Earth orbit. We'll say this is Hermes. So, like, as you can see, the Hermes spacecraft is in a circular orbit. How do we calculate the potential energy of this spacecraft? There's a very simple law. Potential energy equals to negative gm1 m2 over r. And r here is the distance between the Hermes spacecraft and the Earth. Then what is g? G is like Avogadro's number in chemistry. M1 is the mass of Hermes. M2 is the mass of the Earth. G, the big G in this case, is called a universal gravitational constant, which is applicable to every single case we're going to deal with. Now, as I said, universal gravitational constant is like Avogadro's number. It is insanely small. Well, universal gravitational constant, in this case, is like Avogadro's number. It's a constant, but it is too small to actually write down every digit of that number, so we just use this symbol. I'll give you the exact value of the universal gravitational field for your convenience sake. Universal gravitational constant equals to 6.67 times 10 to the power 11, and the unit is Newton meter squared over kilograms squared. So from now on, instead of using the traditional MGH potential energy formula we learned in grade 11, we're going to use this equation instead to calculate the potential energy of Hermes spacecraft in low Earth orbit, low Martian orbit, and so on. Thank you for watching my lecture, and have a good one.